Hello everyone, welcome to MindSpan education. So in last video we were discussing about multiple random variable and we started discussing with two random variables for an experiment. We say that this random variable x and we have the random variable y, and these two random variables are associated with the same experiment and we know their individual PMF. So this probability mass function tells everything about this random variable x, and this probability mass function tells everything about this random variable y. And we wanted to answer this kind of question. So what's the question? The question is, what's the probability that random variable x takes the value 1 and simultaneously this random variable y takes the value 2? What's the probability of that? By knowing the individual probability mass function of these random variable, we will not be able to answer this kind of question. Why? Because we need to have the information about how these two random variables are related. Last time, instead of giving the relation between these two random variable explicitly, what I gave you is directly this PMF. I assumed that this random variable x is taking some value from the finite set, as well as this random variable y is taking the values from the finite set. If this is the condition, we will have the joint probability mass function that will look like this, right? And this joint probability mass function contains the information that how these two random variables are related. Here I cannot say directly how these two random variables are related, but this information is there. If I have to fetch this information, I would be able to fetch this, but let's not worry about that. So yeah, once we have this table, we will be able to answer this kind of question, right? Or if we have the info about how these two random variables are related, we will be able to answer this kind of question. Many students would have this doubt that from where you are getting this table directly. So this is very genuine and obvious doubt. Let me first of all discuss on that. So maybe this is this table, that this data I have got from long-term experiment that was going on, and based on this long-term experiment, based on the observation, these are the experimental data, or these are the based on the observation I have got. Since it was from the long term and someone has recorded or someone has made the observation in long term and they have given me this joint PMF. Or if you are still not satisfied with me, then what you can do, you can simply think of a classical probability example and you can start from the scratch. Let me give you a hint. You can start from an experiment. Let's say you are tossing two coins independently. So if you are tossing the two coins, what will be the sample space? Maybe you will get both of head, maybe you will get first head then tail, or maybe you will get tail then head, or maybe you will get on the both tosses tail. This is the sample space that you will get with tossing the two coin. Now we know that for an experiment we can have multiple random variable. Let me define a random variable x. So this name x is the random variable, that is the number of heads, and let me define one more random variable y, and this random variable y is the number of tails. What are the values that this random variable x can take? Maybe you will not get any head, so random variable can take the value 0, or maybe you will not, maybe you will get just one head, so random variable can take the value 1 since total number of heads are 1, or maybe on both tosses you will get the head, so total number of heads are 2, so random variable will take the value 2. Similarly, in case of the tail, so random variable y will take also the values 0, 1, 2. Let me write down these things. So if you observe here carefully, so random variable x can take the value 0, 1, 2. Similarly, random variable y can take the value 0, 1, 2. Right? And if you observe, these two random variables here are dependent and they have the relation. What's the relation and how they are dependent? And one more thing I wanted to mention here, I still haven't talked about the dependency or independent of random variable, which I will talk in next few videos. But I just wanted to show you that from the experiment, that how you are getting the probability mass function and how these probability mass function are related to happening of some events, right? So these probability mass function, as I earlier mentioned, that they will be directly into your exam, or they will be directly given to you based on underlying some experiment or long-term experiment, or based on the observation. But I just wanted to show you, and that is why I have taken this classical example, right, where we are tossing these two coins independently. So if since these two coins we are tossing the independently, these are the possible outcome that we will get, and each will have the probability that 1 by 4. The occurrence of each will have the probability 1 by 4. We define two random variable x and y associated with this experiment, and how we define this random variable is the number of heads in two flips, and y is the random variable, that is the number of tails in these two flips. And here we are able to determine based on the nature of the experiment that these two random variables are dependent. How? If you look at the sum of these two random variables, they will be always equals to 2. How? Maybe you will get this outcome, that is head. At that time, this random variable x will take the value 2, and this random variable y will take the value 0 since there is no tail. So 2 plus 0 is 2. Or maybe you will get this outcome, or maybe you will get this outcome. In this case, x will take the value 1, y will also take the value 1. Similarly for this case, and in this case x will take the value 0 and y will take the value 2. So every time you will get the sum of these two random variable will be 2. If you know y, you know x. So these two random variables are dependent. Let me mention one more time. I will be discussing about the dependent and independence of random variable in further videos. Alright, now you can just simply draw the PMF of this random variable x, individually this random variable y, and you can also have the joint PMF of this random variable x and y happening simultaneously. So these are the outcomes, that is head. You can have outcome could be head or head tail, or tail head and tail. And if it is head, random variable x will take the value 2. If it is head tail, random will take the 1, and here 1 and here 0, because x is how we have defined is the number of heads in two flips. In case of y, if it is head, there is no tail, so the value will be 0, and here 1 and here 1 and here 2. Hope it is clear. There is no confusion here. So this is the PMF of and every one will have the probability that is 1 by 4, right? 1 by 4, the occurrence of the probability that this event will occur, all will have the same probability, that is 1 by 4. Since these two random variables are, since these two events are that we are tossing the coin is independently, right? And each will have the probability 1 by 2 times 1 by 2. And one more point to observe here, you see that these two tossing these two coins are independent, but these two random variables are dependent, right? Oh, okay. Now let's look at the joint PMF. So what is this joint PMF? So joint PMF, we calculate the probability that random variable x will take some value little x, and at the same time y will take the value some little y. So here at this moment we know everything that we should know in order to find the joint PMF. We know the how these two random variables are related, right? So if I ask you that what will be the probability that random variable x takes the value 2 and random variable y takes the value 0, what will be the probability of that? Random variable x takes the value 2 and random variable y takes the value 1 is equivalent to saying that which event has occurred. So we are getting 2x, so x is taking value 2 and y is getting value 0. That means we have on the both tosses we have got the head and head. And what's the probability of that? It is 1 divided by 4, right? We can answer for each and every possible pair that random variable x and y can take simultaneously. We can even question that what will be the probability that random variable x can take the value 1 and simultaneously y can take the value 1. By asking this question, what's the underlying event? The underlying event, so random variable is taking the value 1, that means out of two tosses one is head, that is why this random variable x is taking the value 1. So total number of tosses are 1, sorry, total number of heads in two tosses are 1 and total number of tails in two tosses are 1. So this is equivalent to happening of these two event, that is the probability that we have. So this event would have occurred, or maybe this event would have occurred, right? So we will simply add these two probability and we will have this, that is 1 divided by 2, right? So similarly we can answer for each and every possible pair of this x and y, right? We can have the probability that what will be the probability that random variable will take the value 0 and random variable y will take the value 2. So what does this mean? This says that there are no heads and there are 2 tails out of these 2 tosses, and this is equivalent to saying that which event would have occurred. So tail, and what's the probability of that? It is 1 divided by 4. If I ask you what will be the probability that random variable x can take the value 0 and random variable y can take the value 0. For this scenario, this is the impossible event, right? If we are tossing the coin 2 times, sorry, if you are tossing the coin 2 coins simultaneously, so either we will get head or tail. So this is saying that you haven't got any head and you haven't got any tail, so this is kind of impossible event. So the probability of that event would be 0, right? So you can now form the PMF for each and every possible outcome. So random variable x can take the value 0, 1, 2, and at the same time random variable y can take the values 0, 1, 2. So these are the impossible event where random variable can take the value 0 as well as random variable y takes the value 0. This is also impossible, and this is possible that random variable takes the value, random variable y takes the value 2 and random variable x takes the value 0, and it has the probability that is 1 divided by 4. So this is the random variable y taking the value, and this is the random variable x taking these values. This will be 0 and random variable x take the value 1, 1, so this will be 1 divided by 2, and this will be also 0, right, because random variable takes the value 1 and random variable at the same time random variable y takes the value 2. This will be also 0, right, because the sum cannot exceed 2, right? So here if you add 1 plus 2 is 3, so this is also impossible. This will be 1 divided by 4 where, and these will be impossible event for this case. So this is the joint PMF for this particular experiment. The motto of this to show you that how these joint how we are getting these joint PMFs, right? So every time you will not given the complete experiment, you will have the abstract information in form of the maybe in table or in form of some other way, and you will be asked directly to find this probability, or maybe in some cases you will have the classical examples or classical problem, and from there you will have to find the relation, and then you will have to find this joint PMF. So the motto was to just show you that how you can get the joint PMF from the experiment. So here you see at this joint PMF, so if I give you this directly the joint PMF, you will be able to answer this question, right, without knowing the underlying relationship, how these two random variables are related to each other. So this joint PMF contains the information that how these two random variables are related. When I started the joint PMF or with this multiple variable, then I directly gave you this. So I told you that just assuming some probabilistic model, and we have defined two random variable and we have given these two probability mass function, and then I asked this question, right? I didn't give you the complete picture of the experiment, and also I didn't give you the relation between these two random variable, and also at that time this table was not existing. So in order to answer this question, now I think you are clear that you need to have the info about that how these two random variables are related. If this info is not given through an experiment, then you must will have this table, and just now you saw that this table contains the information that how the random variables are related to each other, and you will be able to answer this kind of question. I hope this is clear. Now let's proceed further. Let me, for the time being, let's stick to this experiment. We started with this experiment tossing two coins independently. We listed down all the possible outcome, and from the basic axioms we know that if we add up all these probabilities of these possible outcome, they will add up to 1. So in terms of event, we can say that maybe this event will happen, or this, or this, or this, right? And this is the probability of occurrence of each event. Let's proceed further. The same way, we can say that random variable x will take the value 2. So behind the scene, what we are saying that this event has occurred. Or maybe we can say that random variable can take the value 0. So what we are saying indirectly, that this event has occurred, right? So this is the PMF, that is the probability mass function of this random variable x, and these are the associated probability of random variable x taking this value. And again, if you exhaust all the possibilities that random variable can take the value, and you add up all the probabilities, that will add up to 1. Similarly, because these are, if I say that random variable x takes some value little x, so these are again the probabilities, right? And from the basic axioms, if you adjust all the possibilities and you add all the probabilities, then it will add up to 1. Similarly, for this random variable y, if you say that random variable y takes the value 2, that means this event has occurred. And if you exhaust all the possibilities and you add up all the probabilities that random variable can take, let's say little y, then those probability will add up to 1. Now similarly, in case of the joint PMF, maybe this event will occur, or maybe this, or maybe this, or maybe this, right? Any of the possibilities may happen, and if you add up all these probabilities, they will add up to 1, right? If you said this, that random variable x is taking the value 2, simultaneously random variable y is taking the value 0, behind what you are saying that this event has occurred and it has a probability 1/4. Similarly, you can talk about all the possible pair, right? And if you add all the probabilities of all these possible pair, they will add up to 1, because at the end behind you are saying that some events had occurred in terms of the joint PMF or in terms of the PMFs, right? So that is why it is very important to understand the random variable. Alright, so what we can conclude from here now, and let me show you here. If any joint PMF that you have given with known experiment or with this observation, the point is that they should exhaust all the possibilities, and if you add up all those probabilities, they should add up to 1. So when you add over all the possible pair of x and y, this exhausts all the possibilities, and therefore their probabilities should add up to 1. So what I am saying, let me write it in terms of the mathematics. So probability, so I am talking about this PMF, joint PMF, where this can take the value, x can take the value little x and y can take the value little y, and if you add up all the possibilities, so you can run over on y and x, right? So this probability will add up to 1. So this is from the basic axiom. Okay, so once we have in our hand these joint PMF, we can use this to find the individual PMF of random variable x and y, and these individual PMF are called the marginal PMF. How do we find them? We will see in the next video. Thank you.